Hi there. Now for this question, we're given that a parabola C has equation y squared equals 4ax, where a is greater than 0. And the points P with coordinates ap squared 2ap and the point Q with coordinates aq squared 2aq lie on C, where P doesn't equal 0 and Q doesn't equal 0 and P doesn't equal Q. And what we've got to do in part A is show that an equation of the tangent to the parabola at P is py minus x equals ap squared for 4 marks. And then in part B, write down the equation of the tangent at Q for 1 mark. So if you'd like to have a go at this, just give you a moment then to pause the video. Okay, welcome back then if you had a go. Now, the first thing I'd want to do is sketch a graph of the parabola. And it's going to look something like this, y squared equals 4ax. And I've shown here the point P, it's just some point on the curve. I've placed it just at this point here and shown its coordinates and drawn the tangent in. So to get the equation of the tangent, all we need to do is differentiate the curve, find out what the gradient is at this point P, and then just substitute this into the equation of the line in the form y minus y1 equals m bracket x minus x1. Standard method, okay, that we should be familiar with. So let's just start this off. If you want to see the work solution very quickly, obviously just fast forward. So we'll take the curve, y squared then equals 4ax, and if we differentiate this, let's just put this in here, differentiate with respect to x, then differentiating this implicitly, we get 2y dy by dx, okay, equals, and differentiate 4ax with respect to x just gives us 4a. So coming down here then, we've got that therefore dy by dx would be equal to 4a divided by 2y, which is just going to give us 2a over y. And so we want that gradient at P, in other words, when y equals 2ap. When y equals 2ap, substitute it into here, we therefore have dy by dx equals 2a divided by 2ap. The 2a's cancel and we end up with a gradient then of 1 over p. So that means that we're in a position now to get the equation of the tangent at P. So just write an intro here. We got therefore equation of tangent at P is, okay, and it's going to take on that form then, y minus y1, y1 being minus then the 2ap there, okay, equals the gradient, which we've just seen is 1 over p, and that's multiplied with x minus x1, so x1 is the ap squared. Now to get it towards this form then, we just need to get rid of the fraction p, so I'm going to multiply throughout by p, and that gives us py minus 2ap squared equals just the 1 times the x minus ap squared. So that's just going to be x minus ap squared. And if we add 2ap squared to both sides and take away x from both sides, we're going to end up with what we had to show. Py minus x equals ap squared. Okay? Now, for part B then, this is very easy because at Q, it's got basically the same properties, if you like, as we had at P. So therefore the equation is going to be exactly the same, only where there's p's, it's just now going to be replaced with a q. So that equation then is going to be qy minus x equals a q squared. I'm just going to write an intro in here though, and that will be just the equation of the tangent okay, at Q is, but nice easy question there. Obviously that's the reason why I just said write down for 1 mark. Okay.